Good afternoon, dear students. Today I am going to teach you knoevenagel condensation reaction. Okay. But before studying knoevenagel condensation reaction, let us have a look on what is the active methylene compounds. Okay. So active methylene compounds. Say for example, malonate ester, now this is structure of malonate ester, okay, in which this methylene group is present in between two electron withdrawing carbonyl groups. That is, this methylene group is adjacent to two electron withdrawing carbonyl groups, and this methylene group is called as active methylene group. Now, why it is called as active methylene group? Because of presence of two electron withdrawing groups. That is, these two carbonyl groups. Okay, these two carbonyl groups of ester withdraw electron towards itself. So, if we react this malonate ester towards base, or if we react any base with this malonate ester, then this base attracts this proton, that is acidic proton, and this results in the formation of carboanion, that is carboanion of malonate ester. And this carboanion is stabilized by mesomeric effect of carbonyl group. That is, this electron withdrawing carbonyl group stabilizes this carboanion. This electron delocalizes towards carbonyl group and pi electrons shift on an oxygen atom. So these are the resonance structure of malonate ester anion. Now concentrate here. In the first structure, the negative charge is present on the carbon atom, so that's why it is called as a carbo. And in the second structure, the negative charge is present on oxygen atom, and this structure is called enole ion, in which negative charge is present on oxygen atom. Okay, electronegative oxygen atom, and because of negative charge is present on electronegative oxygen atom, that's why this enole ion is more stable as compared to carboanion. Okay, so these are the two structures, that is resonance forms of these malonate ester ions. And why this group CH2 group is called as an active methylene group? Because when base attract this proton, which results in the formation of carboanion. Okay, and this carboanion is stabilized by electron withdrawing carbonyl group. It means that carbonyl group help in releasing the proton. Okay, this two carbonyl group helps in releasing the proton, acidic proton. That means there are two carbonyl groups are present in the malonate ester, so that's why each with which the proton release takes place is faster. Okay, so I will give you some more examples of active methylene group. Say for example. This is the malononitride. What? Malononitride, in which CH2 group, that is methylene group, is attached to a carbonyl group of ester, and here cyano group, that is methylene group is adjacent to a cyano group as well as carbonyl group of a ester. See next example. This is the ethyl acetoacetate. Okay, what? Ethyl acetoacetate. Okay, so in which this active methylene group is present. Other examples include diketone is also an example of active methylene compounds. Okay, these are the examples of active methylene compounds. And in which, why it is called as active methylene compound? Because these protons are acidic in nature. Okay, this electron withdrawing group increases the acidity of these protons, methylene protons. Okay, and remember that if acidity depends upon stabilization of conjugate base. Okay, greater the stabilization of conjugate base, greater is the acidity. So here 2 electron withdrawing carbonyl group stabilizes this conjugate base. So that's why acidity of this proton is greater. Okay. So now we will move towards the knoevenagel condensation reaction. When aldehydes or ketones is created with active methylene compounds. Now we have seen the active methylene compounds. Okay, when aldehydes and ketones is created with active methylene compounds in presence of a base like piperidine, or we can take secondary amine also. Okay, when aldehydes and ketones is created with active methylene compounds such as malonite ester in presence of base like piperidine, it gives alpha beta unsaturated compound, and these alpha beta unsaturated compounds on acid hydrolysis use alpha beta unsaturated acid, and this reaction is known as a knoevenagel condensation reaction. Okay, now let us see examples of knoevenagel condensation reaction. CH3 C double bond O CH, that is acetaldehyde. When this acetaldehyde is created with malonite ester, in presence of base piperidine, it gives alpha beta unsaturated compound. This type of compound CH3 CH double bond C COO C2H5 twice. Now this type of alpha beta unsaturated compound on acid hydrolysis alpha and beta. That is alpha beta unsaturated acid. Okay, and this reaction is known as the knoevenagel condensation reaction. I repeat the reaction. When acetaldehyde is treated with malonyl ester in presence of base pyridine, it gives this type of alpha beta unsaturated compound, and when this alpha beta unsaturated compound upon acid hydrolysis, it gives alpha beta unsaturated acid, and this reaction is called as the knoevenagel condensation reaction. Instead of acetaldehyde, we can take any other aldehyde also or ketone also, and instead of malonyl ester, we can take any other active methylene compounds such as malonitrile. Okay, so now let us see mechanism of this reaction. Mechanism of reaction. Now in the first step, CS2 C double bond O C2H5. What happens in the first step? In the first step, piperidine acts as a base which abstracts this acidic proton from the malonyl ester. Now we have already seen that this proton is acidic in nature because this methylene group is adjacent to two carbonyl groups. So that's why these methylene protons are acidic in nature. So this piperidine attracts the proton from this malonyl ester, and this results in the formation of carboanion. That is anion of malonyl ester. Okay, and this anion is stabilized by electron withdrawing effect of carbonyl group. These are the resonance structures of this carboanion. What is the resonance? In simple language, resonance is the delocalization of electrons. Okay, so here negative charge means lone pair of electrons. That lone pair of electrons is delocalized toward the carbonyl group. That is the resonance. It is a carboanion. Okay, this is the first form and resonance form, and this is a enolate ion. And in this carboanion is an enolate ion, in which enolate ion is more stable because negative charge is present on electronegative oxygen atom. So that's why enolate ion is more stable as compared to this carboanion. Okay, now what happens in the next step? In the next steps, this carboanion, that is malonyl ester anion, in the next step, this malonyl ester anion attack the carbonyl carbonoacetaldehyde. Okay, this malonyl ester anion attack the carbonyl carbonoacetaldehyde. We know that carbonyl carbonoacetaldehyde is electron deficient. Okay, so this carbon react with nucleophile. This is electron deficient carbon, and this react with nucleophile. This results in the formation of tetrahedral intermediate. CH3CO negative, CH COO C2H5. Okay, twice. Malonyl ester anion react with acetaldehyde, which results in the formation of tetrahedral intermediate. In the next step, this tetrahedral intermediate attract proton from the water molecule. Okay, this tetrahedral intermediate attract the proton from water molecule, and this results in the formation of this type of compound CH3 CHOH COO C2H5 twice. Okay, this compound on heating, loses water molecule and gives alpha beta unsaturated compound CH formation of carbon carbon double bond CH double bond COO C2H5 twice. Okay, alpha beta unsaturated compound. This alpha beta unsaturated compound on acid hydrolysis gives alpha beta unsaturated acid with elimination of carbon dioxide, that is decarboxylation, okay, and ethanol. Elimination of carbon dioxide and ethanol. Okay, and here formation of alpha beta unsaturated acid. This is all about the knoevenagel condensation reaction. Okay, I will repeat the mechanism once again. Mechanism of reaction. See here, in the first step, piperidine abstract the acidic protons of malonyl ester, which results in the formation of this type of carboanion, that is carboanion of malonyl ester. This carboanion is stabilized by electron withdrawing effect, that is mesomeric effect of carbonyl group, and this is the enolate ion. Okay, in which negative charge is present on electronegative oxygen atom. In the next step, carboanion attacks on electron division carbon of acetaldehyde. This results in the formation of tetrahedral intermediate. Tetrahedral intermediate then extract the proton from water molecule, okay, and forms this type of compound. This compound on further heating loses water molecule, okay. This results in the formation of carbon-carbon double bond, that is alpha beta unsaturated compound, and this alpha beta unsaturated compound on acid hydrolysis, this alpha beta unsaturated compound on further acid hydrolysis gives alpha beta unsaturated acid with the elimination of carbon dioxide, that is decarboxylation, and elimination of ethanol molecule. Okay, so this is all about the knoevenagel condensation reaction, in which we react malonyl ester with acetaldehyde in presence of base piperidine, okay, which results in the formation of alpha beta unsaturated compound, and these alpha beta unsaturated compounds on acid hydrolysis give alpha beta unsaturated acid. Now let us see next example of knoevenagel condensation reaction. Next example of knoevenagel condensation reaction. When benzaldehyde is treated with malonyl ester, CH2C double bond O, OC2H5, CH2C double bond O, OC2H5. In presence of base, piperidine. Okay, when benzaldehyde is treated with malonyl ester in presence of base piperidine, it gives this type of alpha beta unsaturated compound C6H5 CH double bond C COO C2H5 twice. Okay, and this alpha beta unsaturated compound on further acid hydrolysis, it gives alpha beta unsaturated acid, alpha beta unsaturated acid. Okay, when benzaldehyde is treated with malonyl ester in presence of base piperidine, it gives alpha beta unsaturated compound, and this alpha beta unsaturated compound upon hydrolysis gives alpha beta unsaturated acid. Now let us move toward the mechanism of reaction. Mechanism of reaction. Okay. Now, in the first step, this piperidine attract acidic protons, which results in the formation of carboanion. Okay. In the next step, this carboanion attacks on benzaldehyde molecule, that is carbonyl carbon of benzaldehyde. Carboanion attacks this carboanion attacks on carbonyl carbon of benzaldehyde molecule. Okay, as this carboanion attacks on carbonyl carbon of benzaldehyde, the pi electron shift on oxygen atom. C6H5 CO negative, CH C double bond O, OC2H5, C double bond O, OC2H5. Okay. In the next step, this is a tetrahedral intermediate. Why it is called as tetrahedral intermediate? Because here carbonyl carbon has a sp2 hybridization. Okay, and we know that when carbon atom has a sp2 hybridization, then its geometry is planar. Okay, and this carbon is converted to a sp3 hybridized carbon. Okay, sp2 hybridized carbon is converted into sp3 hybridized carbon, and that time geometry changes from planar to tetrahedral. So that's why it is called as a tetrahedral intermediate. Okay. In the next step, this tetrahedral intermediate attracts proton from water. This results in the formation of this type of compound C6H5 COH CH CH, COO, C2H5 twice. Okay. This compound on heating loses water molecule and there results in the formation of carbon-carbon double bond C6H5 CH double bond C COO C2H5. It means formation of alpha beta unsaturated compound. This alpha beta unsaturated compound undergo acyl hydrolysis. Okay. When this alpha beta unsaturated compounds upon acyl hydrolysis, it gives alpha beta unsaturated acid. Okay. So this is the cinnamic acid. Cinnamic acid alpha beta unsaturated acid. That is name of this compound is cinnamic acid. Formation of cinnamic acid. Okay. So this is all about the knoevenagel